All right, you'll notice on this slide that we've got the formula that we just came up with to find the sum of an infinite geometric series. Take the first term divided by 1 minus the common ratio. Let's put that to practice here. A couple of problems we're told to find the sum of the infinite geometric series. So here we're given an infinite geometric series in sigma notation. Now if I'm going to find the sum of an infinite geometric series, again, the key thing is that my common ratio has to have an absolute value less than 1. If it doesn't, if my absolute value of my common ratio is greater than 1, this series has no sum. It's going to keep going to infinity. It's going to diverge, okay, get bigger. I need to converge by having an absolute value common ratio that's less than 1. So, to do this, first I decide does my common ratio have an absolute value less than 1? My common ratio is 1/4, so yes. That being the case, to find the sum, I'm going to take the first term divided by 1 minus the common ratio. So 1/4 is my common ratio. Now what's my first term? Well, plug in 1 into the equation that you're given. 1 minus 1 is 0, 1/4 is 0 power is 1, 1 times 3 is 3. So here's the work I have to do to find my sum. Now be careful with your order of operations. If you're going to rely on a calculator, make sure you put a lot of parentheses around your denominator. Use a little common sense for these problems though. What's 1 minus 1/4? That would be 3/4. So I have 3 divided by 3/4. Remember, instead of dividing by fraction, multiply by the reciprocal. Okay? So I'm going to move this down here. Multiply by the reciprocal, 3 times 4/3. 3 divided by 3 is 1. 4 must be my sum of that infinite geometric series. Okay? It's pretty simple. Next one, now we actually have the series written out. So here, instead of being able to just pick out the common ratio, we have to look for it a little bit. Well, what's my common ratio here? Is there one, and does it have an absolute value less than 1? That's what I have to figure out. To go from -1/2 to 1/4, and from 1/4 to -1/8, I think that I'm multiplying by -1/2. Does that make sense? Times 1 all the way across, times 2 each time I move in the bottom, and the sign changes from negative to positive with each one. Must be -1/2 for my common ratio. If that's the case, and I'm supposed to find the sum of this infinite geometric series, well, I know that it's going to have a sum because my ratio has an absolute value less than 1. Use the formula. To find the sum, we take the first term, -1/2, divided by 1 minus the common ratio, also -1/2. Careful with your parentheses. Numerator, 1 minus -1/2 turns into 1 plus 1/2. Well, that's going to be 3/2. Numerator is still -1/2. Remember, instead of dividing by fraction, we should multiply by the reciprocal. Take -1/2 times 2/3. I notice that the 2's will divide out, cancel, which means that my sum is going to be -1/3. There's the sum of my infinite geometric series, all by using the formula first term divided by 1 minus r.